So we've already seen decision trees, and we talked about the fact that they were versatile algorithm that we can use for regression, but also for classification. But we've also said that one of the issues is that they tend to overfit. Now, there's another method known as random forest that is even more powerful. So let's have a look at what random forest is. So imagine that we take that decision tree that we did before, but instead of just taking one tree, we look at this tree as well as a number of other trees. That gives us the forest. And so the principle behind random forest is to use subset of your total data set to form different trees that will look slightly different. And so the forest is not homogeneous, it's inhomogeneous. And that is precisely the strength of the random forest algorithm. Because this random forest is what is known as an ensemble. And the ensemble is more powerful than each individual tree alone. That's because you create different versions of the decision trees that have different subset of the data, so they're slightly different, and so you're more robust to overfitting. You have less problem with overfitting. And then what happens is once you've created that ensemble, you bring a sample, and the ensemble will give you prediction. In this case, we have 6 trees, so you will end up with 6 predictions. These 6 predictions are then average, and you have a voting system, and there's different algorithm for the voting system, but a very popular one is majority vote. So the majority class is selected, and then you can make a prediction. So random forest is essentially relatively simple once you've understood decision trees, but it really avoids a lot of the issues that decision trees have. Now, although it is more powerful than decision trees, it has also some of the same problems. So hyperparameters such as the depth of each individual tree, for instance, how deep you go in the tree structure, that remains a very sensitive hyperparameter that you need to fix at the beginning. And a new hyperparameter that you can use is, of course, the size of the forest. How many trees do you want? Typically, having several hundreds of trees is preferable, although there's a point where if you're past 300, 400, 500 trees, it starts to level off, and the gain that you get by adding more trees is offset by the computational cost. And you can still very much overfit with random forest, but it is definitely a good algorithm to have in your algorithm bag for both regression and classification.